program on exploration of mathematics in emerging fields. Embrace obstacles, seek chances to gain wisdom in all situations. Offering words of encouragement creates a wave of positivity, uplifting not only the recipient but also spreading inspiration to those around them. I request Dr. C. Janita Nancy, Assistant Professor, to introduce our chief guest.
Good evening to all and welcome for this faculty development program. I'm thrilled to introduce the chief guest of today, Dr. K.M. Manigandan, Assistant Professor and Head in the Department of Mathematics, Dr. S.N.S. Rajalakshmi Arts and Science College, who has warmly accepted our invitation to join us today. Dr. K.M. Manigandan is an accomplished professional and beacon of excellence in the field of operator theory. He has nearly 22 years of teaching experience and 10 years of research experience. He has published 6 books, remarkably, Mathematical Applications of Test of Hypothesis and Linear Algebra, and Mathematical Problems in Estimation Theory and Confidence Interval. He is a versatile personality who has published 18 research papers in national and international journals and conference proceedings. He has completed UGC minor research project titled A Study on N plus K Power Class Q Operators in the Hilbert Space with sanctioned amount of Rs 2,20,000 during 2014 to 2016. In addition, he has guided 10 MSc projects and 7 PG summer internship programs and acted as resource person for many lectures inside the College of Coimbatore. As an added note, he has been awarded as Man of Implicity by Dr. S.N.S. Arcas in the year 2020. He has organized enormous seminars, workshops, and conferences. He is presently acting as Chairman of Mathematics Board of Studies to UG Max CA and Chairman for Autonomous Valuation for both UG and PG Mathematics since November 2011 and many more. Success is most often achieved by those who don't know that failure is inevitable. He's such a successful person who have given special talk on discrete mathematics for MCA and quantitative mathematical analysis for MBA corresponding students of IGNO through radio broadcasting in Nyanvani, Coimbatore. Enter with a happy heart, may all who enter as guest leave as friend. With a wholehearted smile and greatness, I feel privileged to welcome you, sir. Thank you for accepting our invitation. Once again, on Department of Mathematics, I welcome you, sir.
Thank you, ma'am. Knowledge is the guiding star of desire, guiding the journey of the soul towards its destination. May I request Dr. K. M. Manigandan, Assistant Professor and Head, Department of Mathematics, Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore, to take over the session.
Dear faculties of Department of Mathematics and the principal of PPG College of Arts and Science, Dr. N. Muthumani ma'am, and the convener of Department of Mathematics, Dr. V. Ratnakumar sir, and the coordinators E. Janita Nancy. So first, I express my sincere thanks for all of you for accepting to provide this faculty development program to the entire faculty teaching community. So now, it's now I share the screen to you. So once again, good evening to all the participants from various colleges and various departments. Now, the title itself gives a very, the title given to me is a very much interested for me. Now, it is a time needy one also. Exploration of mathematics in emerging fields. The title itself a very capsy one, and we are in a very important time for us to go through on this issue. Now, particularly, it is the now time being, most of the students are mainly focused on the modern data analytics concept. So now it is widely important throughout in the current generation students. They are using it very rigorously, and it provides a lot of job opportunities in the current field. So that's why I have taken this faculty development program for particularly not in go with exactly widely. I'm not concentrating in all the areas. So we have moved into a specific area, and in that we are going to discuss how the mathematical concepts are widely used in the in the area of data analysis. So now my presentation will be considering of only three parts. One is the probability approximately correct learning algorithms and its association with Markov inequality. Then second one is performance measure in data points. The third one is singular value decomposition, linear transformation applications in image processing. So now let me discuss it one by one thoroughly, then from which we can understand that how the mathematics plays a vital role behind these data analysis. Now here, first let us start with probably approximately correct learning process. Now, before touching on the vital concepts like concentration measure, probably approximate control bounds, cross-validation techniques, gradient descent algorithm, a variety of Jaccard distances, L2 distances, LP distance, L0 distance, Mahalanobis distance, and principal component analysis are very essential for nowadays modern data analysis. Due to if we have time constraint, we can discuss the Jaccard distances also. First, we discuss the probably approximately correct learning concept. Now, the probably approximately correct learning defines a mathematical relationship between the number of training samples, the error rate, and the probability that available training data are large enough to attain the desired error rate. Now, we are given there are two types of sets, data sets will be given. One is training data, and the another one is large data, desired data. Now here, the probability approximately correct is a concept. It is derived from the computational learning theory, which was introduced by Leslie Valiant, British American computer scientist and computational theorist in the late 1980s. It provides a theoretical framework for understanding the capabilities and limitations of machine learning algorithm. Now, in this goal, where in probability approximately learning, the goal is to develop the algorithms that can learn from a limited amount of data while still making accurate predictions most of the time. So we are given only the limited amount of data. With it, we have to find the exact predictions most of the time. That is the main aim behind the probably approximately correct learning. The term probably indicates that the algorithm predictions are not guaranteed to be correct for every instance, but they are expected to be correct with high probability. Now, the term approximately implies that the algorithm procedures may not be exactly correct, but are very close enough to be useful. Now, here, a learning algorithm is considered probably approximately correct if a certain level of significance 1 minus delta and a certain level of accuracy epsilon. Here, delta and epsilon are positive numbers. It can produce a hypothesis that at least epsilon accurate with probability at least 1 minus delta. Now, by using the sample size. Now, the accuracy level epsilon is to be maximized with the particular to a level of confidence that we can found the upper bound by using Markov inequality in the coming slides. So now here the input size will be given to you and the logarithm of 1 by delta and 1 by epsilon will also be given. In simpler terms, probably approximate correct learning addresses the question of how much data is needed for a machine learning algorithm to reliably make accurate predictions even in the presence of noise and uncertainty. So it provides a rigorous foundations for understanding the trade-offs between the sample size, accuracy, and confidence in machine learning tasks. Now, before dealing with probably approximately correct, now we want to know about the Markov inequality. So it is very famous inequality in the area of statistics. Now let X be a random variable and it takes the value, positive value greater than or equal to 0. Then for any parameter alpha greater than 0, the Markov inequality is the probability of X greater than or equal to A, which is less than or equal to E of X divided by alpha. Here, E of X represents the expected value of the random variable or mean of the random variable, and alpha is any parameter. Now, this is the basic definition of Markov inequality. Now, what we are doing, we are connecting Markov inequality with probably approximately correct. So by providing the value alpha epsilon equal to alpha minus expectation of X and delta equal to E of X divided by alpha. Now we can reframe it as the probability of X minus E of X greater than or equal to epsilon, which is less than or equal to delta, and we replace E of X, we keep E of X as it is, and alpha by what we are doing epsilon plus E of X. We replace alpha by epsilon plus E of X, and it gives the probability that some random variable is farther than epsilon at most delta. So we explain this concept by giving an example how the Markov inequality is connected with probably approximately correct, and then how it is used in a problem. Now here, let C be a random variable describing the number of liters of coffee consumed by the faculty at a data university. The data will be collected from an university. Now here we see that average number of coffee consumed by the faculties during the week is 20. Now by using Markov inequality, we can find the probability that the coffee consumed will be more than 50 liters. So now we can see the we can apply the Markov inequality very easily. Let C be a random variable denoting the number of liters of coffee from data university consumed in a data university in a week. We are given that E of C equal to 50 and we have to find the probability of X greater than or equal to 50. That means the coffee consumption per week should be at least 50, that we have to find the maximum bound for it. That is, here bound is nothing but again a probability. Now probability of X greater than or equal to less than or equal to E of X by alpha, in which you take X is equal to C and E of X by X is equal to C and alpha by 50, you will get the probability of C greater than or equal to 50, which is less than or equal to 20 by 50, that is 0.4. So therefore, we can expect that the maximum probability, that is the probability of consuming the coffee to be greater than or equal to 50 should be less than or equal to 0.4. Now next we discuss the probability measures that are used in the data analytics, how the concepts are used in performance measure. Now, before getting into this chapter, the performance measure is nothing but the various ideas particularly if you take car consumptions, and that is mostly the performance of it is an idea used to be the classify and analyze the given set of data points will be given to you in parameters like identification of labels, overall performance of a classifier, sensitivity, specificity, balanced accuracy, prevalence, positive predictive value, negative predictive value, direction rate, direction prevalence, observed accuracy, and expected accuracy. All we can find with the help of the performance measure. Actually, now here variety of cars will be given to you. We can identify the performance of the cars based on these are the several criteria under which we can choose the best car. So for this, we use the table, the predicted condition, the total population. Now the predicted condition, sometimes the predicted condition may be positive. In that case, it will take true positive. The expecting performance is also good. Our expectation, suppose we are meeting our expectation as correct, then we will take it as true positive. And false positive means, so our expectation may be wrong, but the reality will be positive. In that case, it happens type 1 error. And here, the prediction condition may be negative. In that case, false negative. Actually, the result will be negative. Our assumption is also false. In that case, type 2 error. We can study in the test of hypothesis. Mostly we have read it. Actually, the data will be correct, but we accept it, we reject it. In that case, it will happen type 1 error. Actually, sometimes the data may be false, but we accept it. That time, we use the type 2 error. In both cases, it's wrong. And when the data is also incorrect and we neglect it, means it is a success rate. Now, it is called true negative. And sometimes the data will be correct and we also accept it. In that case, it is positive, true positive. So now this is a data. With the help of this data, the performance of the cars will be evaluated by the manufacturers. So now there are various performance measures are available. So now let us discuss in a positive manner quickly. Now true positive, false negative, true negative. Now n is the total of all these values: true positive, true negative, false negative. TP represents the correct identification of positive labels. TN represents the current identification of negative labels. False positive represent incorrect identification of positive labels. False negative represents the identification of negative labels. So with the notation, we can find the various measures using the given 4 datas. Accuracy is nothing but overall effectiveness of a classifier and is calculated by using the formula true positive plus true negative divided by total number of cases. And here the maximum value of accuracy is 1. It happens when the classifier exactly classifies 2 groups. False positive means 0, false negative means 0. So now we shall see some remarks also here. Total number of true positive labels we can identify total true positive and false negative. Here total number of true negative labels is here is true negative and false positive. Here we are given the some meanings of it, how the sensitivity is a characteristic, one of the measure. It is calculated and it is defined, and we can, using this formula, we can calculate the sensitivity of a particular car or something. So it is defined as the effectiveness of a classifier to identify the positive labels and is denoted by SE. SE is nothing but the true positive divided by true positive plus false negative. Here the sensitivity also takes the value between 0 to 1. It is also a probable value. And here specificity is defined as the effectiveness of a classifier to identify the negative labels. So for identification of positive labels, we use the formula. For identification of negative labels, we use the formula true negative divided by false positive plus true negative. Now the total value, now here the ideal value for SC and SP value is always equivalent to 1. And we can find the balance accuracy is it is defined as the average value of sensitivity and specificity. Now here the prevalence value also we can calculate it. The prevalence value is the measure of how often the S condition is actually occurs in the given sample, and it is calculated by using the formula true positive plus false negative divided by n. The positive predictive value is the proportion of correct results in the labels identified as positive, and it is calculated by using the formula standard error into prevalence value divided by standard error into prevalence value plus 1 minus specificity into 1 minus prevalence value. It is calculated with the help of PV value. And similarly, we can find negative predictive value. The negative predictive value is obtained by using the formula specificity into 1 minus P divided by specificity into 1 minus P plus 1 minus S into SC into P. Now we can find the deduction rate also. The deduction rate is obtained by dividing true positive value divided by total number of datas. Here deduction prevalence rate is also calculated with the formula TP plus FP divided by N, and then we can find the kappa. Kappa is a statistic metric that compares the observed accuracy value with the expected accuracy value, and it is calculated using observed value minus expected value divided by 1 minus expected value. So now we have given some example that related to you. Now just by applying the previous results, we can find the performance measure table will be given to you 10109. With the help of the performance measures table, we can find the characteristics. The earlier we have said it: accuracy, sensitivity, specificity, prevalence, and then positive predictive value, negative predictive value, detection rate, detection prevalence, balanced accuracy, observed accuracy, expected accuracy, and kappa values. So now the idea behind is that with the by measuring all these type of characteristics, then only the performance of a data can be, the classifier can identify whether the data given to him is correct or not. Now we discuss one simple idea that related to a researcher measures the performance of the two algorithms on a data set. A data set will be given to you. So now we have to assess the performance of the two different algorithms. The algorithm one, the execution types of the algorithms will be given to you for each algorithm. The first algorithm repeated for 5 times. So in the first time, the algorithm takes 10 seconds, and in the second time it provides 12 seconds, third second 11 seconds, and fourth time 13, and 15, fifth time it takes again 14 seconds for completing the algorithm 1. And similarly, when the algorithm 2 is executed, it takes the seconds in order also given. Now, with the help of the algorithms, so which algorithm is performance is more, we can calculate it by simply by identifying mean. That is enough. Now we can see that from the algorithm 1, it takes 12 seconds. While we are finding the by using average value, it takes 12 seconds. For in the algorithm 2, it takes on an average 17 seconds. So when the by comparing these two results, we can conclude that the algorithm 1 is best because its average performance will be it takes less amount of seconds to perform the algorithm, complete the algorithm. So now here we can see that the simple concepts like measures of central tendency, mean, median, and mode standard deviation concepts are widely used by the data scientist for measuring the algorithms. Now, our main aim is focused on linear algebra and machine learning, how they are used. Now, in lower classes, we already studied that. So a number, a scalar is a single number. It has an only it has here vector has both direction and magnitude, whereas scalar has only a magnitude value. So that idea we are going to adopt in the machine learning also. Here, in machine learning, vectors are often used to represent the features of data points, whereas in the images, the image is a vector is an image, and whereas inside the vector, the entries are corresponding to pixels. So now, while we are increasing the data values, then in that case, so now see here, a scalar is a single value, it's like a number, and a vector on the other hand is a quantity that has both magnitude and direction. In machine learning, the vectors are often used to represent the features of data points. But instance, working with images, you could represent each image as a vector where each entry corresponds to a pixel value. Now, see this image. What is happening? The circle is, we have to transform the circle into a ellipse. So it is obtained by 3 rotations. The first one is stretching in the horizontal direction, then compress in the vertical direction. Again, we rotate to a desired clockwise or anti-clockwise. In this case, we have to rotate into the anti-clockwise to a certain angle, then we will get the circle will be transformed to a ellipse. So now we are doing 3 operations here. One operation is rotation, and then after that, what we are doing, compression we are making, and then again we are rotating. So now in this case, the linear transformation ideas are widely used by mathematicians. Now see here, this is a little bit harder, but we can rotate it. Now a circle is given to you. In the top hemisphere, it is the colored with blue, and whereas in the top bottom, it is colored with red. Now we have to transform the circle into an ellipse for the colors should be retained. So this involved 5 stages. First, you have to rotate in the right location. Here what we are doing, the circle is given to you. So we are rotating in the clockwise direction to a certain angle. So therefore, first we get we move the color, desired color, the color to be taken to the top side. So for that, first we make we are rotating to a certain angle. Then after that, what we are doing, we are scaling it. Scaling means, so by making, we can stretch or we can stretch to a certain level by providing the scaling. And next, here, what we are doing here, the stretch it in a horizontal direction. Then after that, stretch vertically. Again, rotate clockwise in a right location. Then we will get a desired figure. Now see here. So now mainly the linear transformation concepts are widely used in this diagram. Now here a circle is plotted, and a matrix is first we before discussing into our discussion what is a linear transformation. A linear transformation is nothing but a matrix defined from the 2 different same vector spaces. Here the vector spaces considering are same. Now what we are doing, we plot a circle. In the two-dimensional space. So by taking the matrix, you consider the matrix here. The matrix is considered as an operator. The first row corresponds to 3, 0, and the second row takes the value 4, 5. You take give the scalar values 3p plus 0q and 4p plus 5q for the matrix A. Here PQ represents the data point. The data points are plotted in the table, and we give circle 1, 0, 0, 1, minus 1, 0, 0, minus 1. We are plotting in this equation. We can find the 3, 4, 0, 5, minus 3, minus 4, 0, minus 5. And while we are plotting these points in the codomain structure, then you will get an ellipse. Now here we are transforming the circle into an ellipse. So now how the image processing is used by the using linear transformations, we can see it now. Now the image here is a dog. So now what we are doing, now we can uplift the dog by a rotation through an angle theta. Then in the second case, scaling or stretching the images. Now mainly we can, the size of the dog shall be stretched or reduced by using the scaling technique. Now here let us consider, let us look at this matrix. So this matrix is here sigma 1 and sigma 2 are the scalars, whereas these are very, very important that we discuss in the problem. Singular value decomposition concept, we here applied it. The sigma 1 stands for the square root of eigenvalue lambda 1, stands for the square root of eigenvalue lambda 2. Now, the sigma 1 stands for horizontal stretching and sigma 2 stands for vertical stretching. So, if you want to stretch any image, it can be done with the help of the eigenvalues, square root of the eigenvalues, that we call it as a singular value. So now the mathematics concept, finding the eigenvalue concepts are used for stretching an image. Here, see here, when the sigma 1 value increases, it gives the stretching along the horizontal direction, and then after that the sigma 2 increases. When sigma 2 increase, you will get a larger amount of the size of the image will increased in a vertical direction. So in simply, finally here we can see it. So finally in the table, the circle is considered to be the circle is converted to the ellipse to a desired level by making an rotation in the clockwise direction, then one stretching along horizontal direction and second stretching along vertical direction, and again to an anti-clockwise direction, you will get an desired ellipse. Now here we can see that how a singular value decomposition is used for rotating the images to our desired level. So now by using the simple matrix 3, 0, 4, 5, so now the matrix is splitted into three parts. The first one is cos theta, sin theta, minus sin theta, cos theta. This is U matrix. And this is, we call it as a singular matrix or diagonal matrix. So whose entries are sigma 1, 0, 0, sigma 2. Sigma 1 is root of lambda and sigma 2 is root of lambda. And again, the orthogonal matrix cos pi, sin pi, minus sin pi, cos pi. So we are making rotations. We are making perform operations from the right side. So now the first matrix is termed as U. The second one is considered as a singular decomposition. That means a singular matrix. And again, this stands for the orthogonal matrix. This is also a rotational matrix. Using NumPy calculation, that means with the help of the NumPy operator, with the help of Math Wolfram or NumPy package in Python, we can calculate the singular value decomposition for a given matrix 3, 0, 4, 5. Here the U matrix is 0.316 minus 0.949, 0.949, 0.316, and here sigma 1 is 6.708, sigma 2 2.2236. Actually, the single value for finding the single value decomposition, the packages are by using the packages, they are directly finding the value. The data scientist people. So now, how the mathematics plays behind it, that we are going to discuss it now. So the first rotation to an negative direction 45 degree, you will get the circle will be rotated to a anti-clockwise and clockwise direction in a 45 degree. See here, the red dot moves to a 45 degree level. And again, so what we are doing in the next diagram, you see here, the 3 root 5 represents the value of the singular value, sigma 1 value. So it shows that horizontal stretching. So now by giving 3 root 5 value, now the circle is stretched along the horizontal direction to a level 3 root 5. And this root 5, there is a second eigenvalue root 5 gives the stretching in the vertical direction. So therefore, here we can see that the size of the ellipse is increased in the vertical direction. So therefore, the singular values play a vital role in scaling the images. Again, we are by using the rectangle formula, we rotate the ellipse to a certain angle in the anti-clockwise direction. So now, in summary, we can see that the operations, how the linear transformation concepts are used here. Finally, what we have done it, a circle is converted into the ellipse to our desired level by using the singular value decomposition concept. The singular value decomposition concept involves 3 operations. One is rotation. The second one is stretching along the horizontal direction. And the third one is stretching in the vertical direction by using singular matrix summation, and then again by rotating in the anti-clockwise direction using the orthogonal matrix. Here U and V are orthogonal matrices. So we can see that with a single image, that is a single image will be transferred to the another level by just by mentioning it as matrices. So we can see here that how the matrix is very play an important role in changing its position, changing its size. So now a very important concept here also we can see it, how the dimensionality reduction plays an important role in the data analysis. Now here, sometime in certain stage, the image will be disappear. So how it will happen? Now we are going to discuss it now. A matrix is given to you, 1.8, 1.2, 4.4, 4.6. This is a matrix. It is represented by a circle, and we perform here also the circle is converted into the desired ellipse level. And here for this matrix, the singular matrices are 6.71, 0.44. So carefully watch this matrix. The diagonal entries are, the main diagonal entries are 6.71 and 0.44, whereas it is a diagonal matrix. So here we can see that the rank of the matrix is 2, because the number of non-zero rows is 2. We can expect it that the rank of the matrix is 2. Suppose the value 0.44 is made as 0, then what will happen? If in the place, if you put it as 0.44 as 0, you will get the number of non-zero rows is 1. Therefore, the rank will be 1. So therefore, from which we can conclude that with the help of the diagonal matrix, that means here the rank is reduced from 2 to 1. What will happen when 0.44 is reduced to be 0? Then the circle, that means the stretching along the vertical direction will become 0. Therefore, in that case, the ellipse will be disappear and it will be considered as a straight line along the x-axis. So now the scaling plays a vital role in the transforming a higher dimension to lower dimension. In this case, a circle in the two-dimensional case reduces to a straight line in the one-dimensional case. So therefore, the scaling is important in the rank concept. In that case, the rank of the matrix will also become 1. So therefore, while we are reducing the rank to a lower level, you will get a transformation, you will get a dimension, the image will be converted into another level. Now we see here. So now the reduction of a rank leads to a reduction of dimension. Here two-dimensional ellipse will become a straight line. Now next we can see how the image process in the how the numbers are reduced to a desired level. If you now see here 1, 2, 3, 4, take a rank code matrix. 1, 2, 3, 4 is a first row. and here -1, -2, -3, -4 is second row, 2, 4, 6, 8 third row, 10, 20, 30, 40 all are the same. Everyone is a multiple of -1. The third row is a multiple of 2 and fourth row is a multiple of 10. So totally we have to enter 16 numbers in the memory space. So now all are there is no need to put all the 16 numbers in the data. So now by just we taking the 1, -1, 2, 10 and 1, 2, 3, 4. Yeah, you write it in the first column and it in the first row. So only 8 numbers are needed to represent the 16 number matrix. Now in that case, the memory size will be reduced, so we can get an accuracy also. So this is if the number of values are 1 million, suppose we are taking 1000 value, the 1000 by 1000 rows and columns, you have to enter 1 million of data in the memory space. So therefore it takes a memory will be very large in that case. So by reducing rank concept, only 2000 numbers are needed. You write 1000 entry, you put 1000 entries in one column and 1000 entries in one row, then you need only just 2000 entries for 1 million entries. So now how a matrix plays a vital role in that means the rank row reducing concept will be very useful for reducing the size of the memory space. Now see here approximation by rank 1 matrices using singular value decomposition. So here we can see that when for higher rank matrices, now see here in this matrix 3141, 5926, 53658, 5358, 9793. So now the rank of the matrix will be here is 4 into 4. So in that case, what we can do? Earlier, the rank of the matrix is 1, but here the rank of the matrix is 4. We are getting a 16 numbers. In that case also, we using the singular value decomposition concept, we make it is approximately rank 1. And here this is a rank 1 matrix and this one is another rank 1 matrix. Some of the rank 1 matrices we are splitting. And we can get the, while we are adding first, while we are calculating while we are calculating the rank on matrix, the rank on the first side and the rank on the second side, you will get accurate images. Now see here, a matrix will be given split it into 3 parts: U summation, V transpose, and the values, the pixel values are given inside it. Here U1, U2, U3, U4 are the pixel values. A vector, it is represented in a vector U, and sigma 1, sigma 2, sigma 3, sigma 4 are the eigen values, and V1, V2, V3, V4 are again a pixel values. Now we have what we have done it. We have split into rank 1 matrices. There is sigma 1 into U1 matrix. You take U1 component and V1 component. And you take next to U value, you take the sigma 2 and you consider the column matrix from U, U2, and here you select V2. And similar way. So now you can see that the value of sigma 1 will be greater than sigma 2, sigma 2 will be greater than sigma 3, and sigma 4 will be greater than, sigma 3 will be greater than sigma 4. So sigma 4 is the tiniest value. So now, when the number of rows, that is the number of decomposition increases, you will get accuracy value. So therefore, we can stop it by to the desired level. First two values alone we can take it. There might be. So I hope that some of you are familiar with it. Actually, now we see here, just by using single value decomposition, by applying single value decomposition just by getting coding from just by entering the values, so they are getting and they have planned to get the exact values. That means exact images they are obtaining. Now, how our mathematical concepts are, by using mathematical calculation, how we can find singular decomposition for a given matrix. Let us see an example here. What happening inside these are all the procedures that we are adapting. In our mathematical background, the data scientists, when they are familiar with these matrix procedures, then only they can write the coding. So that coding alone they are using, and after that the image processing concepts they are applying it. Now see here, these are all the procedures for finding singular value decomposition for a given matrix. A matrix will be given to you. You have to find the A transpose A, and with the help of the characteristic matrix A transpose A minus lambda equal to 0, and you can find the eigen values. And next to here, characteristic vectors you have to find out, and then orthogonal matrix, the characteristic corresponding to each eigenvalue, you will get each eigenvector. The eigenvectors corresponds to Q1, Q2, Q3, and we have constructed the orthogonal matrix. And then we find the singular matrix for A transpose A by applying the formula sigma 1 equal to root lambda 1. This is called the singular value. While in the image processing, they are taking only the largest singular value that I mentioned to you. And we have constructed the singular matrix DA 0, 0. And finally, we get we have decomposed the matrix into P summation Q transpose. One problem we have solved it by using this procedure. A matrix is given to you. We have found out A transpose A. Here we have found the eigenvalues for the given matrix lambda equal to 3, lambda equal to 1, lambda equal to 0. And here, with the help of the characteristic root, with the help of the characteristic equation, we have found the characteristic roots. For lambda equal to 3, we have found out the characteristic vector, and for lambda equal to 1, we have found the characteristic vector Q2, and for lambda equal to 0, we have found the characteristic vector Q3, and then here we have constructed the orthogonal matrix Q by putting Q1, Q2, Q3 values. And you see here, we have found the singular values of A transpose A. And the rank of the matrix is also needed. Now, just I mentioned there, when the rank of the matrix reduced to 0, the images will get compressed and the dimension will be reduced also. So how we can see here that how the rank of the matrix plays a vital role in the reduction of the dimension of an image. And the size singular value, while we are reducing the singular value, it also see here the sigma 3 value here is 0. So in that case also the dimension will be reduced. So now here before setting into, we have to find the orthogonal matrix P1, P2. Here we are finding only P1, P2 because the third eigenvalue is 0. So therefore we have found out the 2 by 2 orthogonal matrix alone. Now we here A equal to P into P matrix is 1 by root 2, 1, 1, minus 1, 1. Diagonal matrix C here, root 3, 0, 0, 0, 1, 0. The last entry we have omitted because the eigenvalue is 0. So in that case also the dimension will be reduced. So and dear faculties, I take too much time. Now the important concept behind is that nowadays the most of the from the students community, what they feel that why necessary I have to study the maths concepts like this. They have a mindset like that. Just by giving the commands, they can find the singular value decomposition. They can find the values directly. But every student must know that for writing the coding, the mathematics concepts behind the mathematics concepts only, the programmers write the coding using the mathematics concepts only, the programmer writing the codings. Only after writing the coding, the neighbors use the the built-in functions. With the help of the built-in functions, they are accuracy level, they are using it as a neighbor. They are using image processing concepts they are using now. Now it is the right time for us to take the mathematical concepts to the present generation students to use it very well. So for this, we have introduced the singular value decomposition to our statistical codes for data analytics students. So what they are feeling that why these concepts are necessary. Just by teaching alone, we cannot take to the student, attract the students level. So now the desired level of the student is entirely different. Now what they are expecting, so by reading these concepts, how can these matrix concepts are used in to their domain. So therefore, it is the right time for everyone of the maths faculties to uh, learn the applications of mathematics and its major significant role in writing the coding part. Then only we can take success, we can take into the students community. So I hope the much of the time I have taken to you. Any queries? Shall we stop or?
Thank you for the informative and innovative session, sir.
Yeah.
Participants, if you have any queries, kindly unmute and
Hello, sir.
Yes, madam.
Hello. Sir, I have one doubt. The example is given of circle converting into ellipse, but in computational geometry, what we do is if we do scaling in x direction and scaling in y direction with different units, we can convert still circle into ellipse. So why we need a single value decomposition?
Yes, madam, it's a nice question. But what they are doing, most of the data analysis, they are using single value decomposition. So while we are referring the IBM syllabuses and most of the data scientists, they are comfortable with um, singular value decomposition concept. So that's why we are taking it. No more, there won't be more changes in the third and fourth. So therefore we can neglect it also. This concept is widely used in image processing. While an image is compressed, an image is represented in a matrix, you will when the image is decomposed into large, medium, and small and tiny, we can omit the tiny areas. Then by adding large, medium, and small, you will get the exact image. The sharpened, while adding the matrices, the image will be sharpened. So we conclude that a coding with fewer entries can save memory space and accurate images also. Now, this is an example we have quoted here. Now see this example carefully. 3141 5926 5358 9793 by using the NumPy package or Wolfram Math, Alpha Math, we have found out the singular value decomposition U summation V and V. Now, as I already stated that it has been split into sigma 1 first component and of U and first component of V, which is written along the row wise, and similarly we have found out large, medium, small and tiny. See here the final matrix you will get when you are multiplying fourth entries, you get exact matrix A. So therefore, we can omit this value, and because almost it represents same. So while we are adding these three ranks, actually we have approximately splitted into rank 1 matrices format. Then we are adding these three matrices, you will get an exact image.
Okay, sir. Sir, can you just explain the last slide of single value decomposition one? in which 4x4 matrix was taken and converted to one, I think, one rank.
This one, ma'am?
No,
This one?
yeah, yes, sir.
This one.
Values were written in that. Yeah.
Rank of a matrix?
Yes.
Yeah. So see here, the previous one, the 4x4 matrix we have given.
So this one, yeah, this slide.
Also 4x4 matrix is given, and there are so many possibilities for we are in the first we have converted into rank 1. Here for you take it for rank 2, higher order rank, or there are some possible ways. In a way, for example, see here, it has four rows and 2 columns. This is also has 2 rows and 4 columns. Finally, you will get 4 rows and then 2 columns. Now, the main idea behind is that the size of the memory space to be reduced. So even though in the diagram, if you take it takes the amount of entries will be very large. See here, totally 8 into it takes here you have to put in this diagram 16 entries you have to put here. But whereas see here, you need only 8 entries. The same matrix can be put in, when it put in different way, the memory size will be increased. So that's why we try to probably we are trying to probably approximately control to rank 1 matrices. Now see here, the same 4x4 matrix can be written in this way also. But writing this way is not an, it takes an, the memory space will be very high. Here you have to take 12 entries and 4, 8, 12 entries. Here also 12 entries. You have to put here 24 entries. So when lower the rank, you will get best accurate results. So at the same time, the memory space will also be reduced. Even though there are some other possible ways for a matrix can be written in some other way, we preferably go in for rank 1 matrix.
Okay, sir. Clear. Thank you, sir.
So now these are all the some references we have done it. A data science for engineers, NPTEL online course, IIT Madras, and the recent book publications, Mathematical Foundations for Data Analysis. It is available in the textbook also. I mean PDF also. You can refer in the website. So these are all recent editions, 2018. So you can refer this book also.
Thank you, sir.
Thank you.
No duty is urgent in returning thanks. I request Dr. A. Maheshwari, Assistant Professor, to deliver the vote of thanks.
Good evening to everyone. It is my privilege to propose a vote of thanks for this enlightening and enriching faculty development program. I extend my polite thanks to our chief guest, Dr. K.M. Manigandan Sir, Assistant Professor and Head, Department of Mathematics, Dr. S.N.S. Rajalakshmi College of Arts and Science, Autonomous, Coimbatore, for accepting our proposal and sharing your vast knowledge with us. Your speech is very inspiring and thought-provoking, sir. Thank you, sir.
Thank you.
I would also like to express our sincere appreciation to all the participants for their active involvement and enthusiastic participation throughout the program. Your eagerness to learn has contributed immensely to the success of this event. Moreover, I extend my gratitude to the organizing committee who have worked tirelessly behind the scenes to ensure the smooth conduct of this program. Last but not least, I would like to thank each and every one of you present here today. Your presence has made this event truly special, and your support has been invaluable. Thank you all, and thanks again.